So you know what is hydrolysis constant? KH. KH is what? KH is equal to concentration of H plus ion in concentration of CH3COOH free acid divided by concentration of acetate ion. So let us keep this equation aside. Now we will see the relation between the hydrolysis constant KH and then Ka and then Kw. You already know what is Kw, ionic product of water. Okay, so now we will see the relationship between these things. And Ka here is the dissociation constant of acid. Ka, it is the dissociation constant of acid. And KH is hydrolysis constant, Kw is ionic product of water. So again, we will consider the same equation, dissociation of acetic acid. So it gets dissociated into acetate ion and H plus ion. Since acetic acid is dissolved in water, we have to consider the dissociation of water also. So water gets dissociated into H plus ion and OH minus ion. So if you want to write the dissociation constant Ka for the acid, how you can write? As usual, product concentration divided by the reactant concentration. So here, product is acetate ion and the H plus ion. So I have written in the numerator, and the reactant is CH3COOH free acid. Now what is Kw? This is a familiar equation you have already seen in some of the previous classes. Kw is equal to concentration of H plus ion and concentration of OH minus ion. Product of concentration of H plus ion and OH minus ion, that constitutes Kw. Now keep this equation as equation number 1 and this one as equation number 2. I have written this previous equation as 1. Just ignore that one. For time being, consider this as 1 and this as 2. Now, you divide equation 2 by 1. This is equation 2 and this is equation 1. So, Kw divided by Ka is equal to what? You can work out separately. Kw is H plus OH minus ion. H plus and OH minus ion divided by Ka. So, what is Ka? H plus CH3COO minus, and this one will come in the denominator, so you can take it up to the numerator. So CH3COOH concentration. Okay, so now H plus ion concentration is common, so we are ignoring that one, and only we are going to write these three: OH minus ion, CH3COOH and CH3COO minus. If you see this right hand side, something is usual, like you can compare with the previous equation KH. Both look alike, almost both look alike. So what we can say is, Kw by Ka is equal to Kh. So if a question is being asked, what is the relationship between Kh, Kw and Ka? Here, if you see, the hydrolysis constant Kh is inversely proportional to the dissociation constant of acid Ka. So it varies inversely with the dissociation constant Ka. For example, if the dissociation is going to be weak, then the hydrolysis constant will be more. So the weaker the acid, greater the hydrolysis constant. Weaker the acid, greater the hydrolysis constant. How you can say? Because these both of them are inversely proportional to each other. Hope you are able to understand up to this point.